We need to know the decibel formula and the earthquake formula. So decibels are equal to 10 log I over I sub t. And then I sub t is 1e negative 12. Okay, so the decibel measurement is a conversion from how much energy the sound has into a number that makes more sense. And the reason we use logarithms is because there's such a huge variability between energies, right? It's an exponential graph. So it looks like this. And when you have to spread things over a huge range, then we take logarithms. So what's really going on here is this will be our decibel measurements, and the logarithm graph looks something like this. So to go from, say, 10 decibels to 11 decibels, or sorry, that's not decibels. To go from 10 decibels to 11 decibels, you need that much power, right? Not too much. But if you want to get to 12, then you need that much more power. And if you want to get to 13, then you're going to need that much more power. So it gets harder and harder to go up. Yeah. So, um, and we can actually figure out how much power it takes to go up 1 decibel, and and that and that problem will help us on what we're going to do today. So, normal talking, you need like say 60 decibels. So if I write 60 is equal to 10 log of I over 1e to the negative 12, how do I solve for I? Divide by 10. So I'm going to divide by 10, and I get 6 equals log of I over 1e negative 12. Now what? We convert to exponents. So 10 to the 6th, 10 to the 6th is equal to I over 1e to the negative 12. Now what? Multiply by 1e to the negative 12. So 10 to the 6th, divide that by 1e negative 12, and I get, oh, you're right, you're right. 10 to the 6th times, not subtract, times 1e to the, oops, not minus, negative 12. And I end up with 1e to the negative 6. So that's 0.0000006. Yeah, you can. But this isn't one of your problems, but this will help you with your problem. So in this case, how much energy does it take to create 60 decibels? Well, 0.0000006 watts. W is watt. Well, I is in watts. So to create sound at 60 decibels takes very little power, right? Well, how much energy is it going to take to create 61? So 61 equals 10 log of I over I sub t. And basically everything's going to be the same except, well, this 6 is going to be 6.1, right? So I can just recalculate this, and instead of 6, I type in 6.1. Okay? So 10 raised to the 6.1 times 1e to the negative 12, and I get point 0.0000. Oh shoot, that wasn't a 6. That was a 1. Okay, so this one is 0.000001, and the new one is 0.00000126. So how much extra energy did it take? Not a lot. Let's find out. Well, if I take this answer and I divide it by 1e to the negative 6, I get an increase of 25%. Right? So that would be an increase that's multiplying by 5/4. So how much do we have to increase to go from 60 to 61? 25%. Okay? But that's going to be harder and harder to do the louder and louder it gets. Okay? So let's see how much energy it takes to create 100 decibels. So 100 is equal to 10 log of I over I sub t. Divide by 10, and I get 10 equals log of I over I sub t. Convert to logarithm, or convert to exponents. 10 to the 10th equals I over 1e negative 12. And then I multiply. So 10 raised to the 10th times 1e to the negative... Oh, I did that wrong, didn't I? I did. I did the other one wrong. No, I didn't. Never mind. No, I didn't. Sorry. Ignore me. Okay? So how much energy does it take to create 100 decibels? 1/100th of a watt. Not a lot of energy, right? But how much bigger is that energy than the original amount? A huge, it's like 10,000 times as big, 1,000 times as big. Right? So to go from 60 to 100, you have to increase your power by 1,000 times. Does that make sense? Okay. And then we could do the same thing for 101 decibels. So I would insert 10.1, and we end up with that same 25% increase. So for every decibel increase, you have to increase your power 25%. It's an exponential graph. So if we started at 60 and we times it by 1.25, or no, not 60. We're talking about the energy. Sorry, that's not going to work. So if every time the energy increases by 25%, if you go from 60 decibels to 100, that's 25% 40 times. And it takes a ton of power to spit out 100 decibels, and 120 would be even more difficult. Does that make sense? And the reason we use logarithms is because those numbers grow so fast, right? That 25% increase grows so fast, we don't want a graph that jumps off the paper. So what we do is we take the logarithm of it, and it ends up looking like a straight line, And then these distances kind of get smashed together. Or actually, yeah, they kind of get smashed together. And you end up with a logarithm graph. Okay. Um, Earthquakes are the same way. And the formula is magnitude is equal to, was it 2/3? 2/3 log of E over E sub 0, where E sub 0 is 10 to the 4.4. So the magnitude is equal to 2/3 times the log of E, which is the energy released by the earthquake, divided by the reference energy, which is 10 to the 4.4. And 10 to the 4.4 is the smallest earthquake that you could feel. Just like in the decibel formula, 1e to the negative 12 is the softest noise that you could hear. Does that make sense? So if we had an earthquake problem, how much energy would it take to create a magnitude 10 earthquake? Well, 10 is equal to 2 over 3 log of E over 10 to the 4.4. I'm going to multiply by 3/2. So I get 30 over 2 is 15 equals log of E over 10 to the 4.4. Convert to exponents. 10 to the 15th. So this is base 10. 10 to the 15th is E over 10 to the 4.4. So 10 to the 15th times 10 to the 4.4 will be my answer. So 10 to the 15th times 10 raised to the 4.4 is 2.5 e to the 19th, and this is in joules. That is a lot of energy. An unbelievable amount of energy. Okay, well, how much energy does a 9 magnitude earthquake make? So if I change that to a 9, then 9 times 3 is 27, and 27 divided by 2 would be 13.5. So I just changed the formula. 10 raised to the 13.5. Oops. 10 raised to the 13.5. And then we'll times that by 10 to the 4.4. That's 7.9 e to the 17th. So how much more powerful is a 10 than a 9? A lot. We need to divide those two numbers. Let's say 2.5 e to the 19th. And we're going to divide that by the answer. That doesn't seem right. Did I mess something up? What did you get? Did you divide them? 31 times seems too big. Where did I mess up? So 10 times 3 over 2 is 30, divided by 2 is 15. If I put a 9 there, 9 times 3 is 27, divided by 2 is 13.5. 10 to the 13 over 2 is e times 10 to the 4.4. Huh, well maybe that is right. So what this is saying is the difference between a 9 and a 10 is it's 31 times more powerful. So the difference between a 2 and a 3 is it's 31 times more powerful each time you go up. a number. Yeah. And so there's such a huge variability in earthquakes. Most of them are in the 2, 3 range. And you can't really feel a 2. What did you get? No. Huh. Let me see your calculator. 10 to the 15th times. But it should be 1e to the 15th, which I guess is the same. 10 to the 4.4. Huh. I'll have to look into that. But in your assignment today, you're going to be using those same equations. So 59 and 60 use the decibel formula. 61 and 62 use the earthquake formula. 63, what formula? Was there a photography formula in the last set? So that would be the same one that's 100. No. So the pH formula we have, and then the information theory formula is given to you. It's the pH formula is back on page 371. And then oh yeah, they're listening to me flip the pages. So 63, in photographic quality assurance, logarithms are used to determine, for instance, the density. Density is the common logarithm of the opacity, which is the quotient of the amount of incident light and the amount of transmitted light. Oh, so it gives you the formula. Let's see if I can figure that out. So it says 63. So D is equal to the common logarithm, which is log base 10, of the opacity, but the opacity is, which is the quotient of the amount of incident light and the amount of transmitted light. So this would be I sub L over I sub T. So you just need to put that in there. So density is equal to the log of I sub L, which is the incident light, divided by the transmitted light, so I sub T. What is the density of the photographic material that only transmits 90% of the incident light? Well, the top would be whatever it is, and divided by the bottom equals 90%. No, all you have to do is put 0.9 in there. So whatever this is, it equals 0.9. So just put 0.9 in there, and it'll tell you the density. Yeah, it's just D equals the log of 0.9. I think so. Yeah, I think that's... there, you can find it back in the last section. All right, and then the last set, 67 to 70, is just catch the mistake.